So, my first question is, how many of you are engineering major students? Please, show of hands. I see, great. In fact, this talk is mostly for you. Why? Because you guys are going to be the ones who will develop new technologies and will deal with the great challenges we have today, like climate change, like pandemic. And you are going to develop disruptive technologies, hopefully, which is very important. Why? Because with disruptive technologies, we can only react to the change of the problems we have today. But it's kind of understood. But what is very important, what I want to deliver during this talk, is that you can actually start doing this now. While you are studying, you don't have to finish your school to graduate to start develop new technologies. So, but the question is, what kind of skills you will gain in this process? So the best way would be to ask the people who are dealing with engineering engagement, or in the people who works with engineering profession. So I will start with one small story. I have one colleague. He has a very interesting job. He is a head hunter for engineers. Okay? So what he does, he looks all around Europe and also in Latvia, and he tries to find an engineer. Then he makes a contract between this engineer and the large company, international great company abroad, and this engineer goes there for a couple of years. And he asked me if I want to have a trial. I've been in engineering for some time, and also I'm at management board of water company, so perhaps I could do something useful, for example, going to Africa. But then I thought, okay, I'm Vice-Rector and I'm professor, and I'm working mostly with students, so I want to spend time working with students. So I said, you know, we have very smart students finishing this year, so why not? Why not to engage them? And he said, you know, we have this policy. We never employ anyone who hasn't been working in the field for 5 years. And I started to think, why it's so? And he said, you know, they don't have a real experience to react to the change. They don't have a really this kind of approach which you will gain when you are exposed to real complex problems. And sometimes there is a problem with attitude as well. So now, I started to look into literature. And if you look at the industry needs for 21st century, surprisingly, you will see that there are only few are related to technology skills. Most of the skills are actually so-called soft skills. Critical thinking, collaboration, communication, flexibility, but these are not like just these everyday skills what we are talking about. We are talking about leadership skills, and this is something what engineering companies want. They want that you, as a future engineer, are doing what engineers are supposed to do. So what engineers are doing? They are solving complex problems. So it's not like a trivial problem you meet every day, and it's also not something you have in your textbook. These problems have no one answer. So by solving these problems, you try to build new things, and this is the way how engineers work. And the second thing is, of course, the motivation and attitude. I know one guy who is very successful startup. He developed his company, which became unicorn. And when I asked him, so what kind of skills do you want from engineer finishing university? So I said, they have enough technical skills. They are smart kids. But what I want is an attitude. I want an attitude which is able to take idea and bring it to the something which works. And of course, this is something we need to teach in universities, because if you think about how world is changing now, world become more and more volatile, uncertain, complex, ambiguous. And it's because of all things happening, like globalization, digitalization, blending of different cultures, etc. So somehow we need to react to this. Now, if you look into skill sets right now, what are demanded for engineers, that engineering is also changing, right? So the statistic shows that we will need more and more of so-called complex solving skills. We will need active learning skills and maybe less of technical skills. So there is some kind of evolution of engineering education as well. But engineers, what we need now, it's not so much how much they know, but rather how much they are able to learn. So why it's so? If you look at the technology change over the last century, so the acceleration pace is almost exponential. So technologies are doubling used to double every 50 years. Now it's 10, maybe 5. So the new technology adoption could be within the span of your study period. You know, you're starting studies, and you know, when you finish, there's another technology there. So how to be able to work with these kind of challenges? And the question is, I think the answer to this is that the core engineering is not applying science. It's more about application of design and of creativity to science. It's a kind of way how to learn to deal with problems. And this is something what you should learn during the studies. This is the only way to learn it is expose yourself to a real problem. So now, if you look at the curriculum of some leading engineering universities like MIT, University of London College, etc., what I noticed, and there's one study done just recently that shows that you have more and more design and problem-solving exercises in early stages of education, even before you learn technical skills, which is kind of strange. But that's what is happening. These are the different type of skills. So what you will find in some of the programs, more than 30 different type of projects students are being exposed to during their studies. For example, MIT, which is well known, engineering university, they have this motto of mens and manus. Now they decided it's not enough. I mean, it's not just hands and mind. You need to also have a deal with the large issues, and you have to build your curriculum around the project. So they're putting projects in front of the studies. So they have all kinds of projects related to machine learning, to digital cities, etc. But it's not always like that. It's not for all universities. So some, if you look at the curriculum, some hasn't changed too much in the last 30, 40 years. And even in the class, when you saw a lot of examples, it could be thousands of them during the studies. The studies show that problem-solving skills are not really being improved. Actually, 1/3 of the students are not able to solve problems which are open-ended. Of course, another problem is what kind of technology do we teach to our students? Do we teach, existing technologies or the ones which are emerging? Most likely the former one. So because of this, we have to change also the way we teach our engineers. And of course, there are other problems like dropout rate. There's not so much cooperation between the faculties. And of course, the motivation of professors are mostly driven by scientific merit. So therefore, I think the approach should be changed as a core for education, should be put on the design ethos. What do I mean by that? It means that you, as engineers, have to be, during your studies, exposed to the difficult problems, and you learn your ways how to solve it on really practical examples, which means working in multiple teams, which means going beyond the state of art, beyond technology readiness, what you have at the moment. So, there are many examples all around the world. For example, the program, which is about engaging students from different disciplines, from different faculty levels. So they are working on technologies which do not exist yet, like automated fruit harvesting, automatic repair, of deep space, something which is not yet there. Or, for example, dealing with problems which are very complex, like bushfire. You know, developing a sensor system for bushfires in California or in Australia requires that you need students from environmental engineering, chemistry, electrical, sensor technologies, etc. Only in this way you can solve this problem. So, and it's normally not happening. So, and also in our university, we have many programs which are mostly hands-on, meaning that, for example, you can build your rocket or you could build your waste plant for the space. And we engage more than 2,000 students with one idea. They have to work with the challenging problems, but there's one attribute which is very important, that you always engage industry. You engage real people working in the field. So they always looking critically what you are doing. During your studies, you are exposed to real problem and to real criticism. So this is how engineers could be taught. I just give you few interesting examples about how students went across the discipline and how students went beyond the state of art. You know, you use drinking water disinfection. You normally use chlorination for that. So there was one group where you have a chemist, biologist working together on develop new disinfection method. And there is this guy who wasn't a biologist. So what he said is, why don't we look at bacteria not from kind of classical point of view when you plate them on the agar plate, but just like a particle, like a bioparticle, because he was in this field. And what happened is that he started to do experiments. And what he realized that these bacteria, which are so-called non-culturable, they are increasing in time. So that actually some of the pathogenic bacteria can grow in drinking water, which means this brings you a new method how you control pathogens in drinking water. Another example is also from my field about membrane filtration. So basically you push water through the membrane, and this is becoming a very popular method because it's kind of simple, but it's very expensive because you have to use a lot of energy. And the main reason is these membranes get clogged with a biofilm, okay, with bacteria. So most of the engineering companies which are selling these membranes, they stop at the point where there's a 90% of water passing through and 10% are just because of the clogging, they are not able to go through. So as soon as you are about 90% of filtration, you stop. So this lady, actually she was from Ukraine, she started to think, but what happens later? You know, is it really stopping the filtration at some point? And guess what? She realized it's not. There are always 10% going through. And then she started to look more deeply on the surface of the membrane. And she realized that on the surface of the membrane, there is some kind of bacteria developing which eats up the biofilm. And this way, the membrane can run forever. So using this method, they have developed so-called gravity filtration approach, which is now used in Africa, which is a very simple, cheap way to disinfect water. Okay, so there could be some skeptics saying, okay, you are just students, you know, so what you can do, you don't have enough knowledge. But then I can just show a few examples from Finland. So there is this student group, they've been developing a satellite. There's nanosatellites, the small things. So what they managed to do as a student, to launch it with a space shuttle and, you know, and test it in the real environment. So this is kind of success. But what is interesting, what was following this? And what was following, they decided to make a startup company. And this startup company now is very successful. They are launching satellites in Finland, and you know Finland is not really a space country, right? Space research country. So basically, the student group were managing to start a new industry in the country. So now, to conclude, I would like to just say a few points. The first, engineering is, of course, always about the risk. All engineering structures are based on previous mistakes. This is the only way we can actually learn how they work. So why don't we build this and move this risk from real outside engineering world into the curriculum, into universities, and expose our students to real risks so they can learn how technologies could be built, and they could develop something completely new. So I saw, before, there are many good examples all around the world how to train engineers, but I think they are kind of marginal. They are not really as a backbone of engineering training. I think this design thinking and problem solving should be in very core of engineering education. And what we can learn from that, as a student, I think what you could ask yourself, while you're studying, have you been exposed to some kind of project and developed something completely new which is not existing yet? If not, I think there's ample activities and opportunities to do so. As a company, I think that what companies can do, and they're actually doing this, they could help to engage students and expose and showing them the mentorship and helping them with the mentorship and critical look from outside. And of course, as a university professors, I think we have to think about different way we teach students. It's more blend learning. Pandemic have shown that we can get professors all around the world, and we can extend our learning outcomes to more flexibility, resilience, and design thinking, preparing us for the change which are coming. So to conclude, I was just want to show this one example. What you see, this is a landfill. The landfill normally is a smelly place. So what they did, it's in Copenhagen, they transformed landfill into this skiing slope. So you can do skiing, do that in the summer as well. And the landfill itself is used as an energy plant. They are burning the trash which is coming from the city, and they have a unique technology making air very clean and removing CO2, making this climate neutral. So I think this is a good example, but there are many other examples that we need to create during the next few years. And I think since engineering is a foundation economy, we are in a turning point of engineering becoming the ones who are changing the world. How engineering education will be able to respond to this change will affect how we will live in future. Thank you.